Okay, ladies and gentlemen, this is the second video for area and perimeter of regular polygons. This video will show the relationships between the various measurements we might be given in a problem. That would be either the apothem, A, the side length, S, or the radius, R. So you'll notice on the screen is a regular hexagon. It's probably not perfect, I drew it by hand, but let's assume that that polygon is a regular hexagon. Now what that tells us is that n is equal to 6. But more importantly, if we look at the picture, you'll notice I've drawn in a triangle. This triangle, it consists of the apothem, the radius, and half of the side length, or the three sides of that triangle. So if we take that triangle and we draw it significantly larger over here so that we can look at it, we should notice that what we have there is a right triangle with a hypotenuse of R, and the legs are A and S over 2. Now this angle down here, we know that measurement. This angle right here is theta divided by 2 degrees. We know that because the entire angle in this particular part here would be theta, and R is cutting that angle in half. It is an angle bisector. So this angle down here would be theta over 2. Now what that allows us to do is it allows us to use SOHCAHTOA to draw up a relationship between any two sides of this triangle. In other words, we can relate any two of those three sides. A, R, and S can be related to each other. So, what we do is we start off by saying, okay, let's say that we want to relate S to R. To do that, we would need to use those two sides of the triangle, which would be the adjacent and the hypotenuse. So we're going to use our cosine to do that. We would say that the cosine of theta over 2 degrees, that's not a very good theta, the cosine of theta over 2 degrees is equal to adjacent, which is S over 2, over the hypotenuse, R. Now that can be simplified rather easily. If we multiply both sides of that equation by R, then we have R times the cosine of theta over 2 equals S over 2. So again, what I did there is I multiplied both sides of that equation by R, which would cancel the R there. Then we do one more step. To get the S by itself, we multiply both sides by 2. Now the main reason we're doing that is to get as many fractions out of that equation as possible. What that gives us is the equation S is equal to 2R times the cosine of theta over 2. 2R times the cosine, again this theta is just not very good, of theta over 2. So that would be our relationship between S and R. Now we're going to repeat those steps 2 more times, only instead of relating S to R, we're going to use a different trig function to relate S to A, and a different trig function to relate A to R. So what I'm going to do is I'm going to step back to here, and now we're going to relate A to R. Now what we know about right triangle trigonometry, A is the opposite, R is the hypotenuse. So this time we would be using sine instead of cosine. Our equation would be that sine of theta over 2 is equal to A over R. Now this one is a much easier equation to solve for a variable, because if we multiply both sides by R, that isolates the A, and that gives us that A is equal to R times the sine of theta over 2, which is our relationship between A and R. We have one relationship yet to discover, and that is the relationship between A and S. So far we've developed 2 equations. Don't worry, they're all going to be put together on the next slide. and they will be made available to you through completed notes on Google Classroom. So our final relationship, we're going to relate A to S. Now if we want to relate A and S, that's opposite and adjacent. So this time we would use our tangent function, and we would say that the tangent of theta over 2 is equal to opposite A over adjacent, S over 2. So at this point, what we're going to do is we're going to multiply both sides by S over 2. That would cancel the entire denominator and would give us S over 2 times the tangent of theta over 2 equals A. Now we can make that a little bit better. We can get rid of one of those two fractions. If we multiply both sides by 2, that would eliminate the over 2 portion of the S over 2. So that would give us S times the tangent of theta over 2 equals 2A, which is the equation we will use when we need to relate the side length and the apothem to each other. Okay, so now we're going to recap here. Essentially what we've got so far are we've developed a perimeter equation, an area equation, an equation for theta, and relationship equations. So here's all of those equations in one place. Area is 1/2 NAS, that's number of sides times apothem times side length. Perimeter is N times S. Theta, which is our measure of one interior angle, is 180 times N minus 2 over N. The biggest mistake people make there is they always divide by 2, they don't divide by N. So make sure you're plugging the same number in for N in the top and bottom of that equation. Finally, our three relationship equations. If we need to relate A and R, we use A is equal to R times the sine of theta over 2. If we need to relate S and R, we would say S is 2R times cosine theta over 2. And if we need to relate A and S, we would say 2A equals S times the tangent of theta over 2. So once again, what do these variables mean? Capital A stands for area, capital P stands for perimeter. Theta is the measure of one interior angle. N is the number of sides. A is the apothem. S is the side length. And R is the radius. Remember that the apothem connects the center to the midpoint of a side. The radius connects the center to a vertex of the regular polygon. And S is the side length of the regular polygon. That does it for video 2. Video 3 will contain our first example. I will probably do each example as a separate video, and there'll be one video for each possible given side, one for radius, one for apothem, and one for side length. Thank you for your time.